these are the previous exam problems. So first one, consider the following figure. So then write each sum of or difference as a single vector in terms of a, b, c and d. The first one is ab plus bc. Okay, start from a, then go to the b this way, then bc. bc is here. So what is the starting point? That is A. So what is the end point? That is C. So the resultant vector should be from starting point to the end point, right? That is AC. Therefore, answer is AC. Actually, you see here AB and BC. So here end point is B and here beginning point is B. So therefore, then you have AC. So you can write AC vector. Next one is CA minus CD. So let me write down in this different way. CA, I write down CD. What is the CD is in this direction CD, but minus CD is other opposite direction, this direction, right? Yes. So minus CD, you see the minus CD vector equal DC vector, right? Therefore, I write down this plus DC vector. Now I write this DC vector plus CA vector. We are using here C end point and C beginning point, right? Then you actually should know the resultant vector is dA vector, but let me show you DC. So D is this, C is this. So DC is that. Then CA is starting point here and begin. Yes, end point is here. So anyway, for whole journey, starting point is D, the end point is A. Therefore, resultant vector is dA. So you see that is dA vector. Right. The last one is dA plus CB plus AC. So how about this way? I can write down dA, then I write this the A endpoint. So I write AC vector, then I write CB vector. Now you see here also AA and CC. So answer should be DB. Let me check. So DA vector this one, then AC is this one, CB is this one. So starting point is D, end point is B. So the resultant vector should be DB vector. Yes, it is right. It is DB vector. Next, second one. A unit cube lies in the first octant with a vertex at the origin. Right. Let me first name this one. This is A. So this one is B. This one is C. And this right. First, let me explain this. What is the O cube? O cube vector. Q is the diagonal, right? A diagonal of the cube. This one, cube. Then how do we start from O and how do we come to the cube? Start from O and come to the cube. Yes, we can start from O and come to this way, that is OA. Then OA vector plus, then go to the AB vector, then go to the BQ vector. You see that? BQ vector. Now you see this is a unit cube. Therefore, OA, what is the OA? We can write that is I because it is on the x-axis. Then AB, it is J. It is parallel to y-axis. And BQ, it is K. Why? It is parallel to z-axis. And unit vector, right? Because unit cube. Yeah. Therefore, we can write I plus J plus K. Then OR. How do we write OR? R is the center of the face opposite to the XZ plane. Center. Therefore, what I do this one, center mean this half. So I write down that name is D. Okay. Now over. So how do we start from O and come to the R? So let me explain. So you can come this direction OC, right? OC vector. Then go to this CD vector. CD. Then go to the top here dr vector plus dr vector. Now you know OC, it is the y-axis and the length is 1. Therefore, it should be J. Then CD, CD is parallel to x-axis and half of the CB. CB is unit 1. Therefore, CD is 1 half CB, right? 1 half CB. What is the CB? We know it is a unit 1. Therefore, it is ith vector. Then DR. You see DR parallel to z-axis and half of the 1, right? Half of the unit mean cube, right? It means the unit cube. Therefore, this DR is the half of the that length, right? Half of the BQ length. Therefore, we can say 1 half K. So, answer is OR vector is 1 half I plus J plus 1 half K. So, that is the OR vector. Right. Then, next one, part B, find the angle between OQ and OR. How do we find the angle? Yes, to find the angle, we can consider a dot product. So, how do we do it? OQ dot OR equal magnitude of OQ plus magnitude of OR and cosine theta. Theta is the angle between OQ and OR, right? So if you draw OQ is like this and OR may be like that. So this is the theta. Think that way, okay? So then OQ cosine theta equal OQ dot OR divided by magnitude. Actually, I write down this way. OQ OR this, right? Okay, then we need to find the OQ dot OR. So how do we find the OQ dot OR? We know vectors, so OQ dot OR equal, so OQ is 1 1 1, OR is 1 half 1 1 half. So answer is 1 half plus 1 plus 1 half. You know how to do it. Multiply these two and the last two, right? Then answer is 2. Okay, right. Then we need to find the magnitude of OQ, and magnitude of OR. So what is the OQ? You see that OQ magnitude is square root of 3 and magnitude of OR, it is 3 over 2 root, right? Therefore, plug the numbers here. So then you will get 2 divided by root 3 times root 3 over 2. The answer is 2 root 2 over 3. From this, we can say theta equal cosine inverse 2 root 2 over 3. So that is the theta. Next one, sketch the curve represented by this. Okay, here we have x equal 3 cosine theta and y equal 4 sine theta, and theta range is this. So what I do, I get the cosine theta is x over 3 and sine theta is y over 4. So now we know cosine square theta plus sine square theta equal 1. We know it. But what do we need to do? By eliminating the parameter and finding the corresponding rectangular equation. Yes, we need to sketch this. First, we need to find the rectangular equation. How do we find the rectangular equation? That is the relationship between x and y. So now we are trying to get a relationship between x and y and removing cosine and sine theta. Okay, so then cosine square theta, we know that is x over 3, therefore this is x squared over 9 plus this one y squared over 16, right? Because sine theta equal y over 4. So then this equal 1. Okay, so what is this? This is actually an ellipse, right? How do we draw this ellipse? So when you draw, you need to show the special properties here. So the x, this is, you can write down x squared over 3 to power 2 plus y squared over 4 to power 2 equal 1. Therefore, this goes, this is 3, then go this way, and like this. Okay, this is not a good picture, but yeah, you see that this is kind of, let me draw a little bit nicer. So this is, yeah, so for the y is the, this should be 4 like this, then I will go that way. Okay, yes, so this should be 4 is better, right? This should be -4, this should be -3, this should be 3. So that is actually an ellipse, right? Parametric equation is what? This is the parametric equation, x equal 3 cosine theta and y equal 4 sine theta, and a rectangular equation is this rectangular equation. Find the vector projection of B onto A if A is given and B is given. Okay, how do we find the vector projection? Yes, vector projection is, you know, project vector projection of B. Yes, B vector B onto A. B onto A. This equal A dot B divided by A to power 2 dot, sorry, is divided by this one, is actually constant scalar, and time vector A. So we need A dot A, right? A dot B. A dot B is 420 dot 111. So this is 6. Now we know A dot B and we need magnitude of A. So magnitude of A to power 2. What is the magnitude of A then? 4 to power 2 plus 2 to power 2 plus 0 to power 2 square root, then it's second power, therefore this, right? This is 20. Now we can find the project A B equal 6 over 20 times A. What is the A vector? Vector A is 420. Now we can write, 2 is common, so you can take out 2, then 10 and 5, right? Then 3 over 5, this become 2, 1, 0. So that is the vector projection of B onto A. Then we have points A, B, C and D also, and asking calculate the length AB and AC. Okay, how do we calculate the length AB and AC? Yes, so let me show you. Maybe this is A and B and C. Maybe this is D. I just draw this way. I don't know how it look like, but I just draw this way. So calculate the length AB. Okay, let me find the AB length. Okay, before we find the AB length, let me find the AB vector. So how do we find the AB vector? You know it is B minus A. What it mean? 1 minus 2 and negative 1 minus 2, negative 4 minus 5, right? So AB vector is, this is negative 1, negative 3 and negative 9. Then AC, right? Okay, from here, how do we find the length of AB? Length of AB is the magnitude of the AB, right? So then 1 to power 2 plus negative 1 to power 2 and negative 3 to power 2 plus negative 9 to power 2 and square root. So this equal 91 square root. Okay, now how do we find the AC? AC vector, the similar way you can write AC. So AC is this. So this vector, yes, C minus A, 3 minus 2, 1, 3 minus 2, 1, 10 minus 5, 5, right? Because you see AC these two, so then 3 minus 2 and 3 minus 2, 10 minus 5, this one, right? So this is 1, 1, 5. Then we need AC, this magnitude, that is the AC length. So then we can say onto this one, that is 27 square root, that means 3 root 3. So that is the length of AC. Then asking the angle BAC. Angle BAC means this angle. So we know AB and AC. Therefore we can use cosine theta. As I explained before, I will write here cosine theta is, I say AB dot AC divided by AB and AC. So we need to find the AB dot AC. So you can find it because I explained before. So that is negative 49, and then the AB length we already know, that is 91 square root, and AC is 3 root 3. From this we can say theta equal cosine inverse negative 49 divided by 91. Actually this is, I write down, not this is a 27 square root, 91 times 27 square root this. So that is the theta value. Show that AD is perpendicular to both AB and AC. How do we show the AB and AC? AD is perpendicular to AB first, right? First, we need to find the AD vector. Do we know AD vector? No, actually we can find it. Why? We know A is 225 and D is 863. Therefore, AD vector 8 minus 2, 6, 6 minus 2, 4, 3 minus 5, negative 2, right? That is the AD vector. So then we can get AD dot AB. AD is 6, 4, negative 2. AB is, we know, negative 1, negative 3, negative 9. So what is this answer? You see that negative 6 and negative 12 and then negative 18 and positive 18. Therefore, answer is 0. That means dot product is 0. Dot product is 0 means AD perpendicular to AB. Right? Similarly, you can get the dot product of AD and AC. That is dot product of AD and AC. So we know AD 6, 4, negative 2 and AC 1, 1, 5. Yeah, this is also 0. Therefore, we can say AD perpendicular to AC. Right. Then find the vector V that has magnitude 2 and in the same direction as the vector, right, 4i plus 3j. How do we find this? Yes, find a vector V. Okay, this is the vector V, right, that has magnitude 2. Okay, then magnitude, that means vector V magnitude has 2 and in the same direction as the vector. Okay, we have another vector 4i plus 3j. Then how do we find the V? Actually, vector V equal, if we know the magnitude of V and unit vector in that direction, right? Now we need to find the unit vector in that direction because we know the magnitude, it is 2. Okay, how do we find the unit vector? We know a vector in that direction, this, that is the 4i plus 3j. So how do we find the unit vector? We have 4, 3 and divided by the magnitude of that vector, right? It means 4 to power 2 plus 3 to power 2 is square root. So this equal, I write down 4 over 5 comma 3 over 5. So this is the unit vector in that direction. Okay. So now actually what I use here, this is the, I explained in the class, unit vector equal any vector, I say W vector divided by magnitude of W. Okay, that is the theory I apply here over here. So then actually I can explain, I can write here V vector magnitude is 2 because that is the magnitude. Then unit vector in that direction 4 over 5, 3 over 5. Therefore, as a final answer, we can say 8 over 5 and 6 over 5. This is the vector V.